record this. So the title today is Completing the Square. And I'm recording this in first period on November 4th. And our target, describe the steps for solving a quadratic equation by completing a square. So this whole first page is going to be like just writing the steps out. And trust me, you are going to want these steps when you're solving these problems. You're going to want to be able to refer back to them. So I know it's a lot of words to write, but you're going to need them, okay? So don't get lazy on me and like, I don't need to write that down. You do need to write that down. All right, so step one. Rewrite the equation in the form ax squared plus bx equals c. Rewrite the equation in the form ax squared plus bx equals c. So when we factor in quadratics and when we use the quadratic formula, we always want everything on one side and 0 on the other side, right? But when you're using completing the square, we always want the constant to be on the right side of the equation. The constant is the number that doesn't have a variable. And we want the quadratic term and the linear term on the left side. Quadratic term is the term that's being squared. Linear term is the term where x has an exponent of 1. Constant on the other side, okay? So that's a little bit different. Sometimes it'll already be that way, sometimes it won't. Next step, you're going to divide all terms of the equation by a. Divide all terms of the equation by a if a is a number other than 1. Divide all terms of the equation by a if a is a number other than 1. If a is 1, then you don't do that part. Just when you divide by 1, it doesn't change anything, right? Step 3 is where this method gets its name. We're going to complete the square. Complete the square. To do this, figure out what b divided by 2 quantity squared is, and then add this number to both sides of the equation. This will create a perfect square trinomial. On the left side of the equation. There's 6 steps. We're halfway there. Next step, super short. Step 4. Factor the PST using the shortcut. Factor the PST. By PST, I'm talking about perfect square trinomial. PST, perfect square trinomial, using the shortcut. We don't know the shortcut yet. Usually I teach a whole day on perfect square trinomials so that you can easily recognize them, but we didn't this time, trying to make up for lost time. But we'll do that today within this lesson, okay? So right now you don't know how to do that. Step 5, take the square root of both sides of the equation make sure, super important, you know when we solve quadratics, we always get 2 answers, right? So if you don't do this part, you're only going to get 1 answer, and that's only halfway correct. So make sure to take the positive and negative square root of the right side of the equation. Last step. Write 2 separate equations and solve each one for the variable. Write 2 separate equations and solve each one for the variable. And it's important to note this method will always work to solve a quadratic equation whereas factoring will not always work. So sadly, because I prefer factoring over anything, but factoring doesn't always work because, first of all, your graph does not always cross the x-axis. So when that's the case, you're not going to find your solutions by factoring, okay? Quadratic formula does always work to find your solutions. Completing the square does always work to find your solutions. Graphing will work if your graph crosses the x-axis. Graphing will work. But you're not going to get an exact answer, so you just plug this into Desmos. Desmos will give you the rounded decimal answer if it is irrational, but you won't get the exact answer, but you can get a good idea. Quadratic formula always works. Completing the square always works. Okay? So let's do some examples. And I have, before y'all ask, 4 examples to do. Okay? Example 1. And I'm just going to write the directions on the first one. Solve by completing the square. Bless you. We have 3x squared minus 12x plus 6 equals 0. So step 1 from our previous page said rewrite the equation in the form ax squared plus bx equals c. Equal c, c is the constant. That means if all of your constants need to be on the right side, because sometimes you'll have more than one, put them on the right side and combine like terms. In this case, we only have one constant, 6. Remember, your constant is the number that does not have a variable. We want it on the right side of the equation. So what would we do? Subtract 6 from both sides. So I have 3x squared minus 12x equals negative 6. Step 2, divide all terms of the equation by a if a is a number other than 1. What is our a in this case? 3. So it's not 1, so we need to divide all terms on both sides of the equation, okay? So we're going to divide each term by a. You want that leading coefficient to be a 1 is the deal. So 3x squared divided by 3 is x squared. Negative 12x divided by 3 is negative 4x equals negative 6 divided by 3 is negative 2. Next step, complete the square. Okay, so like I said before, we did not spend any time on perfect square trinomials. Remember when I taught y'all about difference of two squares? A perfect square minus a perfect square is a special case called a difference of two squares, and there's a shortcut to factoring it. Remember that? Okay. I'm gonna pretend like y'all said, yeah, we remember that. Well, there's another perfect case called a perfect square trinomial. Okay, it's when you have 3 terms. The first term's a perfect square. The last term's a perfect square, and the last term's always positive. And your middle term is the square root of the first term times the square root of the last term doubled. Okay, that's a perfect square trinomial. It'll make more sense when I show you on when we get one. The goal is we're trying to create a perfect square trinomial on the left side of the equation. Okay, that's going to help us solve the equation. We're trying to create a perfect square trinomial. So, like in my original problem, my first term was 3x squared. That's not a perfect square. My last term was positive 6. That's not a perfect square. So there's no way that can be a perfect square trinomial. So we're going to force it to be a perfect square trinomial. Okay, so when we move that 6 over to the other side, we divided by a to get rid of that 3. So now, isn't my first term a perfect square? X squared is a perfect square, right? Okay. Now, what I'm doing is I'm going to complete the square. And whatever that number is, I'm going to add it to the left side and the right side. The method that we use to do that will force this term for C to be a number that when I take the square root of it and multiply it by the square root of the first term and then double it, it's going to give me my middle number, okay? That's going to create a perfect square trinomial. That's the goal, okay? So the direction said complete the square. To do this, figure out what b divided by 2 quantity square is and then add this number to both sides, okay? I'm going to do this over on the side. Complete the square. You take b, divide it by 2, and square it. We're not talking about our original b, we're talking about our new b, okay? Not the original b, the new b, the new b. So b is negative 4. So I'm going to substitute that into that little formula that I gave you. We can simplify inside parentheses. What's negative 4 divided by 2? Negative 2. Negative 2 quantity squared is what? Positive 4. Because negative 2 times negative 2, positive 4. Right on? Okay. So it said, take b divided by 2, quantity squared. We did that. And then add this number to both sides of the equation. This will create a perfect square trinomial. Okay. We're going to add this 4 to both sides of the equation. I add it to the left side. I add it to the right side. So on the left side, I have x squared minus 4x plus 4. None of those terms are like terms. I can't combine any of them, so I just write it in standard form. So that's x squared minus 4x plus 4. And on the right side, negative 2 plus 4 is 2. It does not matter what's on the right side of the equation, okay? It matters what's on the left side. We created a perfect square trinomial. So again, let me show you. Perfect square trinomial is a trinomial, has 3 terms. Your first term's a perfect square, right? What's the square root of x squared? X, because x times x is x squared. Your last term, the 4, is a perfect square. What's the square root of 4? 2. And your last term has to be positive to be a perfect square trinomial. The middle term can be positive or negative. Last term has to be positive. So it's the middle term. You have to make sure you check the middle term. So the middle term has to be the square root of the first term times the square root of the last term doubled. So we said the square root of x squared is x. The square root of 4 is 2. Multiply those together, you get 2x. Doubled is 4x. It doesn't matter what the sign is. Okay? Absolute value of the middle term. Think of it that way. So this is a perfect square trinomial. Whenever you have a perfect square trinomial, you can factor it using a shortcut. If you don't remember the shortcut, you can still do t-chart divide and slide, right? A would be 1, B would be negative 4, C would be positive 4. So you would need 2 numbers that multiply to give you positive 4, add to give you negative 4. What would that be? Negative 2 times negative 2. So your factors would be x minus 2 times x minus 2. Whenever you factor a perfect square trinomial, your factors are always identical. It's 2 of the same factors. So if you don't remember how to do the shortcut, just do perfect square trinomial, or just do a t-chart divide and slide, okay? But here's a shortcut. So we know our factors are going to be identical. So the shortcut says you make one set of parentheses, but you must square it because you're going to have 2 identical factors. You must square it. The sign between the two terms is going to be whatever B sign is. Remember, C always has to be positive for a perfect square trinomial. So it's whatever the sign of B is. So the sign in the middle is a negative. Your first term in your parentheses is going to be the square root of the first term. So what is the square root of x squared? X. That's going to be your first term. The second term in your parentheses is the square root of the last term, that positive 4. The equals 2, we're not looking at that. That's not what we're factoring right now. So what's the square root of 4? 2. Okay, that's the shortcut. And we already said if we did two-chart divide and slide, I'll just do it over here on this quick so you can see. A would be 1, B is negative 4, C is positive 4, right? Two numbers that multiply together to give you A times C. A times C is positive 4. And add to give you B. B is negative 4. We said this out loud. Negative 2 times negative 2 would give you positive 4. Negative 2 plus negative 2 would give you negative 4. So two sets of parentheses. X would be the first term. And you have a minus 2 in both sets, right? Whenever you factor a perfect square trinomial, your factors will be identical. So we can rewrite this instead of x minus 2 times x minus 2. That's the same thing as x minus 2 quantity squared. That's what we did over here. We just did it in a shortcut. You can only do that if it's a perfect square trinomial. Okay? Our whole goal was to create a perfect square trinomial, so we could factor it that way. That's when we're factoring. We're not factoring. Okay? So completing the square, different steps. We're only looking at the left side, and that's all we're factoring. Quantity squared. So did you see over here, the left side was negative 2 times negative 2. The right side was negative 2 plus negative 2. So in my parentheses, x minus 2 times x minus 2, right? And a is 1, so I didn't have to divide and slide. And when they're identical, you can write it as one factor, but you got to square it. Okay? And we'll do several examples. So that's your phone. That's your phone. Put that in your backpack. Next step. Oh, step 4, factor the PST using the shortcut. We just did that. Next step, number 5, take the square root of both sides of the equation. Make sure to take the positive and negative square root of the right side of the equation. Okay, so on the left side, I'm going to take the square root of x minus 2 quantity squared equals, on the right side it said take the positive and negative square root of the right side. You know how when we do quadratic formula, it's always plus or minus the square root, right? So that's kind of the same as what we're doing there. We need two answers. So one will be the positive square root and one will be the negative square root. Don't do that on the left side, only on the right side. What is the square root of x minus 2 quantity squared? It's just x minus 2. The radical sign goes away, the exponent goes away. X minus 2 equals positive or negative, or you can say plus or minus. Is 2 a perfect square? Does 2 have any perfect square factors other than 1? No. So I can't simplify that radical. If I could simplify that radical, I would simplify that radical. Okay? Everybody cool with that? I told you this is a lot of steps. That's why you definitely want to make sure that you follow along with your step-by-step that we wrote on the first page. Step number 6, write 2 separate equations and solve each one for the variable. Okay, how we get 2 separate equations, remember on quadratic formula when we wrote our answers, 2 separate answers? Because one of your answers took the positive square root into account, the other answer took the negative square root into account, just like that, okay? So I'm going to write 2 separate equations. One of them will be x minus 2 equals the positive square root of 2. And the other one will be x minus 2 equals the negative square root of 2. A lot of kids want to change the x minus 2 and make it x plus 2. You don't do that. It's only the right side that's positive or negative, okay? And then we just solve each equation. You're trying to get x by itself. So we're going to, on the left side, add 2 to both sides. So x equals, that's going to be 2 plus the square root of 2. I cannot add those together. You don't put 2 right next to the square root of 2 because that's 2 times the square root of 2. I cannot add those 2's together. 2 plus the square root of 2 is not the square root of 4. Okay? That's all I can do. That's one of your answers. On the other side, I'll add 2 to both sides. And that's going to give you x equals 2 minus the square root of 2. That's as far as I can go unless I turn it into a decimal. And on your test, you're not going to have decimals. Decimals are a rounded answer for the most part, if they're irrational. Radicals are an exact answer. So wasn't that easy and kind of fun? Okay. Yeah. Correct. So yeah, right here, it's the negative sign is on the outside of the radical, so that would not give you an imaginary root. It's only if there was a negative under the radical that you would get an imaginary solution. And I think one of my examples is like that. Oh, no, I didn't. But yeah, if it was under the radical, then you would do the imaginary. All right, example 2. So this one, I'm going to speed it up a little bit, except for when we get to this one part, when there's a fraction. I have 2x squared minus 2x plus 3 equals 9. Step 1, rewrite the equation in the form ax squared plus bx equals c. Notice this time I have 2 constants. 3 is a constant and 9 is a constant. So one of your constants is already on the right side, but I need all constants on the right side. So what would I do? Subtract 3. First step, easy breezy. So we have 2x squared minus 2x equals 6. Sometimes I like to leave a little space for my new constant, whatever constant's going to be. Because look, 2x squared, this is not a perfect square trinomial. 2x squared is not a perfect square. 3 is not a perfect square. Not a perfect square trinomial. We're trying to create that. That's the process that we're doing. Next step was what? Divide all terms by a. If a is 1, you don't have to do that part. You can go to the next step. But a is a 2. So divide all terms, even on the right side of the equation. So 2x squared divided by 2 is x squared minus 2x divided by 2 is x equals 6 divided by 2 is 3. So x squared, our first term is now a perfect square. We have to figure out what is our last term going to be in order to create a perfect square trinomial. So that's when we complete the square, step 3. Complete the square. To do this, figure out what b divided by 2 quantity squared is, and then add that to both sides of the equation. And remember, it's not your original b, it's your new b. What is our new b? Not x, not 1, negative 1. Negative 1 divided by 2 quantity squared. Okay, so I know it's a fraction. 1 does not divide by 2 evenly, does it? Don't turn it into a decimal. Think of it like this. Isn't negative 1 divided by 2 quantity squared? That's the same thing as negative 1 divided by 2 times negative 1 divided by 2, or negative 1/2 times negative 1/2. We know when we multiply fractions, it's numerator times numerator, denominator times denominator. So what's negative 1 times negative 1? Positive 1. What's 2 times 2? 4. So is 1/4 a perfect square? Yeah, because Perfect square is when you multiply a number by itself to get the perfect square, right? Negative 1/2 times negative 1/2 gave me 1/4. So the square root would be positive 1/2 or negative 1/2, because 1/2 times 1/2 would also give me 1/4. Negative 1/2 times negative 1/2 also gives me 1/4. So I am adding a fraction to both sides. I get x squared minus x plus 1/4 equals 3 plus 1/4. Hey, isn't 3 cups of sugar plus a 1/4 cup of sugar 3 1/4 cups of sugar, right? So 3 plus 1/4 would give me 3 1/4. But you don't want, if it's a fraction, you don't want it to be a mixed number. You want it to be an improper fraction, okay? So we could do 4 times 3 is 12. 12 plus 1 is 4. 12 plus 1 is not 4. 12 plus 1 is 13. And the denominator stays the same. So 3 plus 1/4 is equal to 3 1/4, but we don't want it as a mixed number. We're going to turn it to improper. So again, you do denominator times the whole number, add the numerator. So 4 times 3 is 12. 12 plus 1 is 13. The denominator remains the same. So that's what I'm going to simplify. The right side is 13/4. Okay, so we have created a perfect square trinomial. It's a little bit harder to see because of that fraction, but I'll walk you through it. So a perfect square trinomial is a trinomial to start with, 3 terms, right? My first term's a perfect square. Is x squared a perfect square? Yeah. My last term's a perfect square. I'm talking about the 1/4. We're not looking at the other side of the equation. Didn't we say that 1/2 times 1/2 is 1/4, or negative 1/2 times negative 1/2 is 1/4? So that makes 1/4 a perfect square. You have to check the middle term too. What's the square root of the first term? X. What's the square root of the last term? One-fourth or negative 1/4. Let's just go with a positive. And then, so 1/2 times x is 1/2 x doubled. When you double 1/2, don't you get a whole? Half a cup of sugar times a half cup of sugar times 2, you're going to have a whole cup of sugar, right? So the whole, and your middle term is the coefficient's 1. Just think about the absolute value. So that is a perfect square trinomial. A little bit harder to see when it's a fraction, but it is. We created a perfect square trinomial by using this process. That's what our goal was. So once we've done that, now we're going to factor the perfect square trinomial using the shortcut. So the shortcut, you make one set of parentheses, but you have to make sure you square those parentheses, okay? Because remember, when you factor a perfect square trinomial, the two factors are going to be identical. So instead of writing them separately, you just write one parentheses and you square it. The sign between the terms is going to be whatever the sign of b is. So in this case, that's a negative. Your first term is the square root of the first term. What's the square root of x squared? X. Your last term is the square root of the last term, the 1/4. We're not looking at the other side of the equation. What was the square root of 1/4? 1/2. Fractions aren't the most fun, but you're going to see them, so I gotta teach you how. Next step says, step number 5, take the square root of both sides of the equation. Make sure to take the positive and negative square root of the right side of the equation, okay? So we're going to take the square root of x minus 1/2 quantity squared. We don't do positive and negative on that side. Equals, we do take the positive and negative square root of the right side. Now that's a fraction. I could do one big fraction bar or a radical sign, I'm sorry. I like to do it separately. I like to put a little square root over the numerator and the square root over the denominator, because sometimes it's easier for kids to simplify when you think about it as the numerator being separate from the denominator, because you can take the square root separate on a fraction. So What is the square root of x minus 1/2 quantity squared? X minus 1/2. Only thing that happens is they're inverse operations. Your radical sign disappears and your exponent disappears. Equals positive or negative. Look at your numerator. Square root of 13. Is 13 a perfect square? No. Does it have any perfect square factors besides 1? No. So I can't simplify the numerator, so it will stay square root of 13. Look at your denominator. Is 4 a perfect square? What's the square root of 4? 2. Not square root of 2, just 2. Perfect square, so it won't have a radical in the answer. Julio? Step number 6. Write 2 separate equations. Solve each one for the variable. So I'm going to write 2 equations. One will be set equal to the positive square root of 13 over 2. The other one will be set equal to the negative square root of 13 divided by 2. Okay? Make sure you don't write the 2 under the radical. 2 is not under the radical, only the 13. And the other equation, x minus 1/2 equals the negative square root of 13 divided by 2. Then I will solve them both separately. So on the left side, I'm going to add 1/2 to both sides. So x equals, these are not like terms. I cannot combine them. I just write them separately. 1/2 plus the square root of 13 divided by 2. You're probably not going to see an answer on multiple choice that looks like that. They both have the same denominators. So you would probably see that as one fraction. Both of these fractions have a denominator of 2. So we can make a giant fraction and just put a 2 in the denominator and write the numerator together. 1 plus the square root of 13. We see answers like that when we solve using the quadratic formula, right? Nothing will reduce. If it could, I would. But nothing will reduce, so I'm going to leave it like that. On the other side, I'll add 1/2 to both sides, just like I did in the previous one. And I get x equals, these are not like terms, I cannot combine them, 1/2 minus the square root of 13 divided by 2. 2 separate fractions, the denominator is the same, so I can write it as one fraction. The whole fraction is over 2. The numerator is 1 minus square root of 13. That's your answers. Anybody have a question? Yes. If it's an emergency. Everybody cool? All right, I have 2 more examples. So the good news is on your homework, I'm only giving you 3 of these for your homework. Not 8, just 3. Because there's a lot of steps. You need to make sure you do your homework. All homework assignments are worth 100 points. When you turn it in late, you will not get any more than half credit on your homework. It's got to be done on time. Also, if you're new to me and you're used to using notes on your tests, in my class, you cannot use notes on your test. You have to know how to do the problems without your notes. You might have to study. That's okay. All right, first step. What are we going to do for our first step? Add 13 to both sides. So that gives us 4n squared minus 8n equals 23. Oh, I used the wrong color, dang. I've been trying to keep them color coordinated with my steps from the beginning. change that real quick. Next step. Thank you. Divide each term by A if A is not 1. So 4n squared divided by 4 is n squared. Negative 8n divided by positive 4 is negative 2n. And 23 does not divide by 4 evenly. We don't want to turn it into a decimal. You don't want to turn it into a mixed number. You can reduce it if you can, but 23 fourths can't be reduced. Say what? Oh, no. 10 plus 13 gave me 23. Right? 10 plus 13, yeah. Okay, next step, complete the square. To do this, figure out what b divided by 2 is and then add this number to both sides of the equation. So remember, you take your new b, not your original b. What is our new b? Negative 2 divided by 2 quantity squared. So what's negative 2 divided by positive 2? Negative 1. Quantity squared means negative 1 times negative 1, you get what? Positive 1. I have to add that to both sides of the equation, not just one side. You just add it to one side, and you have changed the meaning of the problem. So on the left side, we have n squared minus 2n plus 1 equals, all right, 23 fourths plus 1. That's going to give us 1 and 23 fourths. But like I said on the last one, you don't want to leave a mixed number. Change it to improper. So 4 times 1 is what? 4, and 4 plus 23 is 27. The denominator will remain the same. Can I reduce 27 fourths? Nope, so 27 fourths. I have created a perfect square trinomial. Let's just check it. It's a trinomial. My last term's positive. My first term's a perfect square. N squared's a perfect square. 1's a perfect square. Just because the first and the last term's perfect square doesn't mean it's a perfect square trinomial. You have to check the middle term. So to check the middle term, take the square root of the first term, which is n, times the square root of the last term, which is 1. 1 times n is n, right? Double it or multiply by 2, and you get the absolute value of the middle term. N times 2 is 2n. Perfect. That's a perfect square trinomial. So, perfect square trinomials, we can factor using the shortcut. If you don't remember the shortcut, use T-chart divide and slide. Shortcut, when you have a perfect square trinomial, one set of parentheses, you must remember to square the parentheses. What's going to be the sign between the terms? Negative, because it's whatever b is. Your first term is the square root of the first term, which is what? N. Your last term is the square root of the last term, which is what? Easy peasy. We good with that? Okay. Got my color coordinating again. It's doing so good. All right, step 5, take the square root of both sides. Make sure to take the positive and negative square root of the right side. So we're going to take the square root of n minus 1 quantity squared. And we're going to take the positive and negative square root of the right side. It's a fraction, so just to make it less confusing, I'm going to put individual radicals in the numerator and in the denominator. Okay, what's the square root of n minus 1 quantity squared? N minus 1 equals plus or minus. Okay, first of all, let's do the denominator first. What's square root of 4? 2. Numerator, is 27 a perfect square? No, but I know it has a perfect square factor, right? What are factors of 27? 9 and 3. 3 is prime. And 9 has factors of 3 and 3. So my factors are 3 times 3 times 3. Does 27 have a perfect square factor? If you have two identical factors, that makes a perfect square, right? So isn't 3 times 3 times 3 the same thing as 9 times 3? Okay, so the square root of 27 is the same thing as 9 times 3. If you have a perfect square factor, you have to simplify. You have to take the square root. My students who have been in here with me the whole time, we spent a whole day on simplifying radicals. If you're new from e-learning, you may have missed that class. I think you did. I posted the video of simplifying radicals, me teaching it on Schoology. You might need to go watch it. So then anything that's a perfect square, we take the square root. What's the square root of 9? We put a 3 on the outside. That comes from the 9. What do we do with that 3, this other random 3? That's not random, but you know. It stays under the radical because we can't take the square root of it. We can if it's a decimal. We're not doing decimals. So we're going to replace the square root of 27 with 3 square root of 3. Step number 6, write 2 separate equations and solve each one for the variable. So one equation I will set equal to the positive 3 square root of 3 divided by 2. And the other equation I will set equal to negative 3 square root of 3 divided by 2. So we're trying to get n by itself, solving an equation. So on my left equation, I'm going to add 1 to both sides. And I get n equals 1 plus 3 times the square root of 3 quantity divided by 2. Now, when you're doing your homework, if this was your answer, I would be totally satisfied with this answer. This is a true and correct answer, and it's in simplest form, okay? Nothing can reduce. I'm good. But if this was the answer on your test, I've told you this when we were doing quadratic formula, your test doesn't like it like this. It wants both of your fractions to have the same denominator, okay? So that's the way it's going to write your fraction. So obviously 3/2, I can't turn that into a whole number, bless you, unless I do a decimal, and we don't want that. But can I turn a whole number into a fraction? Yes. I need an equivalent fraction. It needs to be equal to 1, but have a denominator of 2. What would that fraction be? Bless you. 2 over 2, because what's 2 divided by 2? 1. So I'm just going to rewrite 1 as a fraction with a denominator of 2. To make it equivalent, it would have to be 2 over 2. You're not going to see it written like that on your test either, because the software that I use, when you have 2 fractions with the same denominator, it's going to write it as 1 fraction. It's going to be a big fraction with just 1 denominator of 2. And then it'll put your numerators together, 2 plus 3 square root of 3. They mean the same thing, but this is the way you're going to see it if it's multiple choice on your test, okay? And remember, your tests with me are, for the most part, multiple choice, so you need to be aware of this. And if you have to take a test retake, it will not be multiple choice. So if that was the case, I would take it like 1 plus 3 square root of 3 over 2. That would be fine. I'd give you credit either way. My other one, my other equation, I'll add 1 to both sides. So you get n equals 1 plus, oops, not plus, 1 minus 3 times the square root of 3 divided by 2. I'm going to do the same thing I just did. I'm going to write it as 1 big fraction, but I have to turn that 1. I need to make an equivalent fraction. So I will change 1 to 2 divided by 2. And then because they both have the same denominator, just like on the left side, except for it will be 2 minus 3 times the square root of 3 quantity divided by 2. Coolio? All right. we have one more example, example 4. I'm gonna go through it pretty quickly. You have all these examples to look back at. You have your steps. I'll post the video before I leave school today, barring any technical difficulties. I recorded this in my 7th period on Monday, and something happened with the upload. The video wasn't, I don't know what it is. So otherwise I would already have it done. So hopefully the same thing doesn't happen with this one, and I can post it. All right, example 4. Four m squared plus 8m minus 11 equals 10. And I'm just going to do this all in one color so that I can speed through it. What do I do first? Add 11 to both sides. So I have 4m squared plus 8m equals 21. I always like to save a little space for my new constant. You don't have to do that. It just kind of helps remind me, oh yeah, we're trying to figure out a new value for C to make a perfect square trinomial. Now what do I do? Thank you. Divide each term by A. As long as A is not 1, you can still divide by 1 if you want. It just won't change anything. So I get m squared plus 2m equals 21/4. I don't want to turn it into a decimal. I don't want to turn it into a mixed fraction. I would reduce it if I could, but I can't. Oh well. Now we want to complete the square. We are trying to figure out what could I add to the left side to make it a perfect square trinomial. Only one number will work. To figure out that number, you do b divided by 2, quantity squared. What is b in this case? Positive 2. So positive 2 divided by positive 2 is 1. And what's 1 squared? 1. So I have to add 1 to both sides of the equation. So on the left side, I have m squared plus 2m plus 1 equals 1 plus 21/4 is 1 and 21/4. You could add those fractions, get a common denominator. You could do it that way, or we can know how to convert a mixed number to an improper fraction. So we do 4 times 1 is 4. 4 plus 1 is 25/4. Oh, and we love when this happens because I know when I take the square root, I can take the square root of 25 and the square root of 4. They're both perfect squares, right? So I like it's a little easier. We won't have to worry about the radicals so much. So we have created a perfect square trinomial on the left side. It's a trinomial. C is positive. My first term's a perfect square. My last term's a perfect square. The middle term is the square root of the first term times the square root of the last term doubled. So that would be m times 1 is 1m, doubled is 2m, boom, we're good. It's a perfect square trinomial, right? So we got to factor it. Perfect square trinomial, shortcut. If you don't remember it, use your T-chart, divide, and slide. But perfect square trinomial, when you factor it, it's going to be 2 identical factors. That's why the shortcut, you make one set of parentheses and square it. What's going to be the sign between the terms? Positive. It's whatever B is. C is always positive. Don't use C sign, it's always positive. Whatever B is. B can be positive or negative. What's going to be my first term? M, because it's the square root of the first term. What's my last term? Because it's the square root of the last term, right? Are y'all good with using a shortcut? You can't use that shortcut on every quadratic. It's only perfect square trinomial, okay? Next step, take the square root of both sides. Make sure to take the positive and square root of the right side. So we're going to do the square root of m plus 1 quantity squared. And we're going to take the positive and negative square root of 25/4, and I'm going to take them separately. Somebody get that door, please. What's the square root of m plus 1 quantity squared? M plus 1 equals positive, negative. 25/4, I can take them both separately. What's the square root of 25? What's the square root of 4? 2. Boom. I don't have a radical in this answer. That's okay. We did quadratic formula where you didn't get a radical in your answer, right? Sometimes you do, sometimes you don't. Next step, write two separate equations. One of them will take the positive 5/2 and the other one will take the negative 5/2. Okay, so on the left equation, I'm going to subtract 1 from both sides. So m equals -1 plus 5/2. If you leave your answer like that, it will not be acceptable to me, or you're not going to see this on a multiple choice answer. We can simplify that. Okay, well, it's really easy to do. How could we write -1 as a fraction with a denominator of 2? -2 divided by 2. Doesn't that simplify to -1? And don't we know, since I have two fractions with the same denominator, can't we put them all, make one big fraction and put my denominator together? Well, in my numerator, usually we have a radical there, but we don't this time. What's -2 plus 5? 3, right? +3 over 2. No radicals in this answer. That's okay. One of my answers is +3/2. That does not mean my other answer is going to be -3/2. Okay? You got to solve it separately. So we'll subtract 1. M equals -1 minus 5/2. We're not going to leave our answer like that. We can simplify it further. If it was the square root over 5, that would be different. The square root of 5 over 2, that would be different. But I can continue simplifying. So I'm going to write -1 as -2 divided by 2. That is equivalent to -1, but it has the same denominator as -5/2, and that will help me simplify, right? So really, I can already see that -2 minus 5 is -7/2, but I'll do it the same way as I did the one on the left side. Since the denominators are the same, I'm going to write one big fraction with the denominator being 2. Then my numerator is -2 minus 5. Well, I can simplify that. -2 minus 5 is -7 divided by 2. That cannot be reduced. I'm not going to turn it into a decimal. I'm not going to turn it into a mixed fraction. I mean, you could, but improper fraction, A-okay. You would probably see on a test, your multiple choice, I believe they leave them as improper when that's the case, okay? Any questions? Okay, so like I told you, your assignment is 3 problems, only 3 problems. So the only assignments we have had before this test, we did solving quadratics, we did solving by factoring, but that assignment was on first quarter, but we did that assignment for this test. When I taught you quadratics, that assignment was Khan Academy. A lot of y'all have not completed that yet. Last class, we did a CUDA worksheet. CUDA is just the type of the software that I use, CUDA worksheet. And that was on quadratic formula and factoring, right? And then today, your assignment is going to be on completing a square. The test is going to be on those 3 methods: solve by factoring, solve using the quadratic formula, solve by completing the square. That's all the test is about. So, if you want to get a good grade, you might want to go ahead and start reviewing those things. A lot of kids say, you can't study for math. You can't study for math. Yes, you can. This is what I would do. This is what I did when I studied for math. I would come back to my notes. I would write this problem on a separate sheet of paper. I would cover up all my work. I would try to work the problem out, see what I came up with. I have the right answer so I can check my work myself, right? It's cheating if you look at the work, though, before you finish the answer. But that's how I would study for tests. You have the correct way, cover it up, and see if you can do it yourself. And you can study for math. Any questions? Yes. Yes. All right. So on your own paper, this is not on Khan Academy, although several of you still have an assignment to finish on Khan Academy. Oh, let me stop this video. Try to stop this video. Please tell me it recorded. No. I can just do this. Bless you.